All right, let's look at Rolle's theorem. So there are three criteria for Rolle's theorem that we need to verify, and I'll show you that it is a quick verification to see that these things are happening. So it has to be continuous between A and B. So that means I'm going to have two different x values that I'm going to start and end at that there you can draw without lifting your pen. Differentiable. So what does differentiable mean? Remember, differentiable means no cusps, corners, endpoints, and vertical tangents. So those graphically are the things that cannot be there for us. The third criteria is that their y values are equal. So I've drawn it that way. Their y values are equal. If I have all of those things happening, what do I get as a result? Then there is a number c that's in between where the derivative is equal to 0. And we can see that on the picture we've got drawn here. All right, so it is necessary you verify, just check, tell me that you know what the criteria are for Rolle's theorem on this interval. You'll always be given the interval. So here's our function, here's our interval. Okay, I know that this function is continuous on this interval between 0 and 3. I know it's a parabola. I can draw it without lifting my pen. Check. So it's just more necessary that you write down that you know what the criteria are. Is it differentiable between 0 and 3? Yes, it's a parabola. Nice round, none of these bad four things happening. The third, you need to go show with algebra. So if I plug in 0, I get 0. If I plug in 3, I get 9 minus 9. That's 0. Check. So the three criteria are satisfied. So now I can go find the number c. So I can find the value of c where the derivative is equal to 0. So I take the derivative, set it equal to 0, I get 3 halves. So c is 3 halves, and that is in between 0 and 3. It's one of the criteria, it has to be there. All right, let's look at this one, x to the 2/3. So you know what that graph looks like. It's important to know your basic graphs, right? And so one, is this function continuous between -1 and 1? Yes, it is. I can draw without lifting my pen. Is this function differentiable between -1 and 1? It is not. We can look at this picture. We can see a cusp here at x equals 0. So it is not differentiable there. So I cannot go and find the values for Rolle's theorem. I'm done. Let's go do this one. So I've got some odd intervals here. Let's think about it. So cosine of 2x, you know this just changes the period. So one cosine wave between 0 and pi, right? Just to get an idea of what's going on. So here's pi over 8, and here would be 7 pi over 8. Okay, there's a picture, so I can think about what's going on with the function. Is this function continuous between pi over 8 and 7 pi over 8? Yes, it is. Is this function differentiable on pi over 8 to 7 pi over 8? Notice every time on the differentiable, I'm not using the endpoints. Yes, that's good. All right, so then the last thing is to check. So if I plug in pi over 8, I get cosine of 2 times pi over 8, so that gives me pi over 4, so that's root 2 over 2. And then if I evaluate at 7 pi over 8, that gives me cosine of 7 pi over 4, and that's root 2 over 2 as well. So check. The y values are equal. So now I can go find the values of x where the derivative equals 0. So using chain rule, I get this. Setting it equal to 0 leaves me to solve where this is equal to 0. So that means I'm going to have pi or 2 pi, etc., right? All right, so dividing through here by 2, I get x is equal to pi over 2 and pi, etc., right? So because I'm only looking for the values between pi over 8 and 7 pi over 8, my one number that satisfies Rolle's theorem is pi over 2.